Today I'll be going through some basic concepts of linked list, and we'll be using Python to create linked list and do some basic operations on them. So what is a linked list? A linked list is essentially a collection of objects that could be combined through a set of pointers. So I'll try to draw here a linked list, a very simple linked list that has three elements, 1, 2 and 3. And I'll also explain what are the elements of the linked list. So essentially a linked list consists of a node. So this is node. A node consists of a data value, and it also consists of a pointer. A linked list also consists of pointers. As I said, the data nodes are connected by pointers, and a linked list has a head and a tail. So the node which has 1 is the head, and the node which has 3 is the tail. One basic understanding of a linked list is that the elements in memory of the linked list, in the memory of computer, are not contiguous. So let's say if this is the memory layout of the computer, this is memory location 0, this is memory location 100, then the linked list element 1 could be at 0 location. The linked list element 100 or 2 could be at location say 90. This is at 0, and element 3 could be at location 50. So, and the way it will get built will be that 1 points to 2, the node 1 points to 2 and 2 points to 3. So this is how the jumps happen. So this pointer will have value 90 associated with it because pointing to the memory location 90, and this pointer will have value 50 associated with it because it's pointing to the location 50. So this is the whole idea that linked lists have elements which are non-contiguous in memory. So that's one of the primary advantages why linked lists are used, elements of a linked list. Now, how do we initialize a linked list? So let's go to a coding exercise, and we'll try and explore how we go ahead and define and use a linked list for its very basic operations. So try linked list with init, and I'll put as Python as the type, right? And so this is, let me just define it again. Suppose it's deleted, and then I'll go ahead and define a file which is linked list with init.py so that it knows that this is a Python file. Great. So now we'll first define a class of the type node. The way we define classes in linked list is you need to define a method which is init to initialize that particular class, and a class is consists of multiple elements. For a node, it will just be a data and a pointer. So we'll pass the self, which is the class itself, then have a data, and then have the next, which is the pointer, and by default this will be none. None means that it is null. So we'll say head self dot header is data, and self dot this should not be header, this should be data, and then self dot next is next. So as you can see, the class node has data and next in it, right? Now we'll try to use this node. So let's say we define an element node which has 3 and the next is none, and we try to print the node itself, the value within the node, right? So here what we've done is that self is being passed by implicit measure, implicitly because the definition of the method, because we're giving the name of the class will call init by passing the self object, and the self object you can imagine is just being the representation of this class object. The data is 3 and next is none. So when we print this node, you will see as I run a little bit in it, right? We get the output as 3. If we change this to, let's say, 1, this would run and print 1. So basically what we've done is that understood how do you use a node. Now let's go and try to define a class which is linked list. So linked list class, we define the init method self and we pass a node to it. And so we'll say self.node is equal to the node itself, right? And the linked list would just consist of a node, or we can call it a header because the header is a much better understanding. And then we'll define a print method on it. So print ll is the method of the linked list. And what we'll do is we'll also take up a current, we'll use an object or a pointer which we will call current, which is the current node that you're pointing to print the linked list. So the way we will try to print the linked list is by having an element which is current. So we'll first point the current to the element 1. We'll print this and we'll then jump current to 2. We'll print this and then we'll jump current to 3 and we'll print this. So the way we do it is we say self.header and then we say while current is not null, which this basically expression means that the current is still active and it's not null, we print current.data and then we move the current handle to the next. So this is just to jump. Now let's say we have this node, we create a linked list with the node and then we say ll.print. So what this will do is create a linked list with the node in it, right? So it will basically call this method and pass the node into header, and then we'll call the printll method, which will basically go through all the elements and print them. So let's try to run and see if I haven't made a mistake, and yes, that's what ends up happening. So this is a single node linked list that we've kind of covered in this lecture. In the next lecture, we'll do more complex operations on linked lists and also try to use the standard library of the linked list of Python. Thank you.